I'm a student of Bennett University in computer science. So today we'll be talking about a very interesting repository on GitHub, that is Camming Hayes Deep Residual Network. It has about 1640 forks, which is really a lot if you see how big GitHub is by itself. Okay, let's see what do we have here. So the contributors here are Coming He, Jiangyu Zhang, Shaoqin Ren, and Jian Sun. So, neural networks are usually rather hard to train, especially when different layers in our network are learning at vastly very different speeds. In particular, when the latter layers are learning well, and the early layers are often getting stuck training nothing at all. Well, what we see before us is an great residual learning platform to ease training of networks that are substantially deeper than before, and this has been used for image detection. Well, let's get into this. This is introduction, and okay. So the repository contains the original models that they have trained for the residual networks at ResNet 50, ResNet 101, ResNet 152 as described in their paper, Deep Residual Learning for Image Recognition. Wow, that sounds lovely. Let's get into it. Okay, they've used cafe, it seems. Uh, all right. Okay, that opens up. We've seen they have cafes versions of okay, show cafe version of Mat Cafe, so you can probably implement the whole thing on MATLAB, which is way more faster and less hefty. And uh, we can since I have read the entire paper. Well, let's just see. Well, I took the time. Okay, there. Okay, this is what the MATLAB code looks like. Well, we cannot exactly run the code right now because it's like way too deep and way too long. But I'll explain on the way what we have in front of us. Well, they as I have analyzed the code, I could see that they had reformulated. Allow me to explain what we have in front of us, the code. well um, we since I had the time to read their entire research paper and their work, let me tell you that they had explicitly reformulated the layers as learning residual functions with reference to the layer inputs instead of learning unreferenced functions. Well, they provided comprehensive empirical evidence showing that these residual networks are easier to optimize and can gain accuracy from considerably incredible depth. Well, isn't that what we want? So that our classification becomes more stronger. And also on the ImageNet dataset that they trained with, uh, they uh, they with up to 152 layers, they had they were 8 times deeper than the VGGNet, but still having a lower complexity, which is an assemble of these residual nets achieves a 3.57 error on the ImageNet test set, and the result won the first place on the ILS VRC 2015 classification task. It says more than it is meant to, and therefore it explains its 1640 forks on GitHub. Well, and that was the deep residual network for you. And I'll be catching up with you soon. Thank you very much. This is Ankit.